Attention, ladies and gentlemen, welcome to another Lean Six Sigma for All session, open session. On a scale from 0 to 10, today I'm using another mic. I'm putting kind of closer to me. I am on an improvised studio. In fact, I am not in Brazil. I am in the United States. But I am doing all my best to touch base, with all my students at least once a week in this open conversation. So please, on a scale from 0 to 10, how is my audio, everyone? Wonderful. Wonderful. Today, I confess to you that I'll be approaching one of my favorite topics. Guys, and maybe you are listening to me kind of closer because I'm speaking not that loud because Arthur is sleeping kind of close to me in the apartments that we live in Brazil. I know about the sound protection, but here in this, it's a kind of apartment too that we are in the US, but I don't know about the sound isolation, So hopefully, once again, you guys can understand my context, and I didn't want to cancel this conversation because I want to touch base with you guys at least once a week. There is something else that I would like to say. That is, this is by far one of my favorite topics in Lean Six Sigma. Capability analysis is so important. This topic is absolutely vital when we talk about diagnosing the size of the problem, but also when we talk about articulating the improvements. When you go to a stakeholder, to an internal client or external client, and you say that the process has changed, you should argue, proving that the change is statistically significant, also that your process is stable, and also that your sigma level has changed. Yes, but before talking about sigma level, it is very important to fully understand Cpk and Ppk. Why? Because Cpk and Ppk are very much used as indices of capability, process capability, okay? They are very much used. Maybe Cpk is globally more famous, I would say more popular, more used than sigma level. A good example of this is automotive sector, okay? So type here, where are you in the Lean Six Sigma journey? Are you a white belt student or certified white belt, certified yellow belt? What's your highest, certification? Certified BB, GB, BB, yellow belt, green belt, black belt, GB in progress, wonderful, handy, white belt, okay, black belt, yellow belt. So the topic that I'll be approaching today is a GB/BB topic. So in case I will do all my best, the name of this session is Lean Six Sigma for All, because I will do all my best to simplify as much as possible, okay? But there are some topics that are more technical, and this is definitely one of them. Once again, even if you are a certified white belt only, stay here with me, because once again, I'll do all my best to simplify this for you, okay? We should not talk about capability analysis without checking process stability. So if you are taking notes, please take note of that. We cannot, or we should not talk about capability analysis before checking process stability. And I say should not. Why? Because on an academic point of view, if we apply full rigor, full methodological rigor, it's absolutely forbidden, to run a capability analysis if you have a process that is not stable, meaning that you have at least one special cause, yes? And I say should, because to be very honest, many times in real life, in real applications, and I say this being a person with 25 years of experience, not always will be able to operate at full rigor. Sometimes we'll do the best we can to, at the same time, meet customer demand with the max rigor that we can apply. And in case we need to make some methodological scenes, we say that. So in case you need to run a capability analysis and the only data you have is from a process that's not stable, and you must run this capability analysis, your customer is truly, pushing so hard that you need to present something. Okay, let's present something, but there is a note. There is a note that this capability study was performed with the only available data that we had in hands, and process is not stable. This is not recommended, but we ran with the data that we had, okay? From 0 to 10, how much did you understand this conversation of, if we want in this planet to operate at full rigor for everything, you should go to academy. You should become a professor at a university. You should become a researcher, okay? Real life, unfortunately, real life, many times, we will not be operating full rigor, methodologically speaking. And then we report that. Because when you report, you say, I did all my best with the data that I had, okay? That I had. And yes, there is a risk. There is a risk, okay? Because, and Marcelo, why can't we run a capability analysis with a process that is not stable? Because capability analysis, CP, Cpk, all indexes, sigma level, they do not talk about the observed performance. They talk about the projected performance. Guys, from 0 to 10, how much are you following me? From 0 to 10, how much are you following me so far? Great question, Annelise. No, so when your process is not stable, what you do is you cannot project the results, okay? You can only say about process performance today, yeah? Because remember, you will be collecting data to run your capability analysis. The recommendation in terms of sample size is 100 minimum, preferably in 25 subgroups of size 4. So imagine, very simple, a chocolate factory, chocolate, delicious, chocolate factory that produces 1,000 chocolates per hour. You go, for example, at the top of each hour and you take 4 chocolates, for 25 hours, a little bit over 1 day. Okay, that would be the minimum, or depending on what we call rational subgrouping, depending on how your process performs, you can take 4 chocolates per day, and then you have a picture of 25 days. 4 chocolates per week, sometimes. And then you will have a picture of 25 weeks. Yes? Are you guys following me? Yes, it's a snapshot in time. Beautiful. And then we take this sample, and based on this result, we are inferring, we are projecting the performance, as we call long term, you know? And it's very hard to present an operational definition of what is long term. 1 month, 1 year, yeah, it's very hard. So we just say that we are predicting future performance. Yes, I like to say max a month, but this is my recommendation based on 25 years of experience, okay? 1 month, we can predict 1 month performance, yeah? When your process is not stable, you cannot predict. So you can only say, let's suppose you took a sample from 25 hours. You can only say about these 25 hours, yeah? You cannot project, yeah? Wonderful. Wonderful. So one thing that is mandatory is to know if your process is stable or not. And by the book, at full rigor, if your process is not stable, you should fix that first. You should understand the causes or the cause behind this special event, treat this cause, and collect another sample, and plot a control chart and check if your process is stable. If it is stable, then you go ahead and then you run a capability analysis, okay? Type understood if you understood that. So let me use here on Minitab, and guys, because I have only one monitor, only my computer today, type here if you can see Minitab. I hope you can see Minitab. Type in our chat window. Oh, let me use my cell phone as my monitor. I believe it will work. Yes, beautiful, beautiful, excellent. Beautiful. And I hope there is no background because of my noise. Because of beautiful. The cell phone being close to the mic. I think the sound is okay, right? Yeah, so let me just generate here some. Yeah, you guys will be listening kind of. Yeah, the sound is good, beautiful. So let me generate here some random data. Yeah, let's see. Chocolate weight, okay? And so I'm gonna generate here some random data. I would say 100 data points, chocolate weight, 10, and standard deviation is 1. A huge variation, huge variation. So let's plot an X bar R. I think, yeah, you guys cannot see. So this is not the best way to... Because I would like you guys to see my One second. Let me try something different here. As you guys are not seeing my window. Yes. The problem is that I have only one. Wait 1 second. Tab full. And then desktop. Primary monitor. Yeah, let's try this one here. Let's see if you guys like this one here. Boom, 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 boom. Let me see. Stat. Yes, yes. I think now we are good, right? You guys can see the menu, because in case you want to replicate what I am doing, it's very important that you see the menu, okay? Very important. So type happy if you are happy with this approach that I'm using. Type happy if you are happy with this approach. So X bar R, why X bar R? Because we have a subgroup size that is less than 8, yes? So chocolate weight, and the subgroup size is 4, okay? So what do I have here? So I have here all my 100 data points, but they are grouped into 25 groups by the size of 4. Do you guys understand that? Do you guys understand that in this data point here, this is the average of the first 4 chocolate weights, okay? And this is the range max minus mean of the first 4 chocolates, okay? Type clear if this is clear for you, and I need to grab a water. Yes, beautiful, beautiful, beautiful. Well, is this process stable or unstable? Is this process stable or not? Stable or unstable? Perfect, perfect. This process is stable. We have no special causes. Just do one more thing. Properties, primary monitor, automatic. Yes, now you have my full screen. Now you have my full screen. Wonderful. So this process is stable because we don't have a special cause here. What would be an example of special cause type 1? If we had, for example, one chocolate that the weight is crazy, you know, it is 20, for example. Then in this case, In this case, we would have a special cause here, meaning there is one subgroup where the range is above the upper control limit. Every time that we have at least one data point that is above upper control limit or below lower control limit, then we say that we have a special cause type 1. Yeah? Special cause type 1. Beautiful. So this is a stable process, so we could go ahead and then run a capability analysis. Normal. Why normal? Why normal? Because I generated data according to the normal probability distribution, but I can come here and run a normality test. In fact, I should always run a normality test first, and in case it is not normal, we should proceed to what we can say it's a special, evaluation, understanding what is the probability distribution behind your data that explains your data. Okay, so normality test and stability analysis is very important, before you run capability analysis. Okay, so now quality tools, capability analysis, and you guys know that because p-value is greater than 0.05, I have failed to reject the null hypothesis, meaning we can say that our data is normal. Yes, it's a double negative. We failed to reject because it's greater than 0.05. So let's go ahead and then run a capability analysis, normal. The subgroup size is 4, and then let's say lower spec is 8. Let's create some problems here, and upper spec is 13. Okay, so how do we read that? We have here basically two probability distributions. See, two probability distributions. One that is red, and red has to do with overall. Let's understand what's overall. And then we have a black, black probability distribution, kind of dotted line, yes, that has to do with within. So our mission today is fully understand what is overall and what is within. Okay, because overall has to do with Ppk. Overall has to do with Ppk. And within has to do with Cpk. Yeah? Ppk and Cpk, they vary from minus infinite to plus infinite. The greater the better. Okay? The greater the better. So we are producing more chocolates that are below lower spec or more chocolates that are above upper spec. Based on what you guys saw here, we are producing more chocolates that it's too light, so probably, considering that the density is the same, we are producing more kind of smaller chocolates that customers are complaining, wow, I have just opened here, and then I see that the chocolate is much smaller than I was expecting. And we have another problem that is, whoa, I have opened here and the chocolate is huge, it's big. That's a problem for our pocket, for the producer's pocket. Yeah, one problem affects more the customer. Yeah, the other problem affects more the producer. But don't think that if you have variation, and sometimes you have a chocolate at the regular size, and sometimes you have too big, regular too big, don't think that this is good. Okay, because customers hate variability. We hate variability. Variability annoys customers. If you are used, to drink this water for the past 10 years, 15 years, you are expecting something when you drink the water. So every time that process variation is completely out of what customers expect, and I say that because all processes vary, but variation must be within limits, and these limits are defined by customers. Okay? So every time that you have a variation that goes way beyond customer is expecting, believe me, your customer will be annoyed. Yeah? So guys, tell me, do you think that we have problems, with chocolates that are above upper spec limit or chocolates that are below lower control limit? Do you believe spec limit? Do you believe that this problem is bigger than this problem here? Yes or not? So see that we are projecting here. We are projecting here. We are projecting. So we are expecting. We are expecting. And if you want just to keep it as simple as possible, you can change options to percentage. So based on this analysis, I am expecting. I'm expecting 2.6% of defective chocolates, because they are below lower spec limit. And I'm expecting 0.25% of defective chocolates that are above upper spec limit. So in total, I'm expecting 2.89. And this number here goes hand in hand with Ppk. And this number here these numbers go hand in hand with Cpk, okay? It's very hard to say like Cpk stands for, Ppk stands for, because you will find that C stands for capability, P, the little p, the small p, for potential, and K is kateori. Kateori is a Japanese word that means you can translate by bias, by offset, or even by location. Yeah, you guys know that translating Japanese words is always a challenge because sometimes there are different meanings. Yes, the same word. And Ppk, some people can say that the capital P is for performance, and then potential, and then kateori again. But the thing is, the main difference between Cpk and type here for me if you know. Type here for me I know, and type I don't know. If you know the difference between Cpk and Ppk and you are here just to refresh or to check, type here I know. From 0 to 10, how much do you know? Where 10 is I know I can teach Cpk versus Ppk, and 0 is Marcelo, I am still trying to understand why are you using this funny. Yeah, it's a little bit let me see if it's adequate for me to say that. I'm reflecting here if I can be in trouble. But it is so hard to teach this in Portuguese because Ppk in Portuguese is the female organ, you know. So every time that I'm teaching Ppk, and I say Ppk, I look to my Brazilian students, and normally I get like 30% of my students trying very hard for not laughing, you know, trying very hard for not laughing. It's a coincidence. It's a sad coincidence for any, you know, Lean Six Sigma teacher in Brazil. Yeah, every time that these three letters show up, I have students laughing. But but from zero to yes, o Matheus. É, Matheus, é difícil, cara, é difícil. Ficou difícil, cara. Ppk. Yeah, and when it shows up in the, I was at the university, depending on the audience, it's not hard, but I had a chance to be at Unifei, Universidade Federal de Itajubá, so full of young students, you know, when I put the slides, Cpk, Ppk, I got almost the entire class, you know, laughing, but it's part of the kind of, it's the same in Philippines. So you know what I'm talking about. Yeah. So you know what I'm talking about. So I got an 8, a 3, a 6, a 10. Okay. 6, 10, 10, 10. Okay, wonderful. So Cpk and Ppk can be calculated by the smallest, the minimum value between what we call CPU or PPU and CPL or PPL. Okay, so let's do that for Ppk. Ppk is the minimum value between PPU and PPL. What's PPU? It's the potential performance associated to the upper spec limit, and PPL is the potential performance associated to the lower spec limit. So what do I mean by that? PPU is upper spec minus mean divided by 3 times the standard deviation. It's simple math, very simple math. No integral, no derivative, no, it's very simple math. Very simple math. Lower spec limit, PPL is mean, process mean, minus lower spec limit divided by 3 times standard deviation. But the thing is, mathematically speaking, there are many different ways for you to calculate standard deviation. There are many different ways. It's not only square root of summation of a mean minus each data point, power 2 divided by n, or n minus 1. N minus 1 if it's the sample, n if you have the population data, you know. But the thing is, mathematically speaking, the only difference between Cpk and Ppk is the way we calculate standard deviation. Period. I'll say that again. Mathematically speaking, the only difference between Cpk and Ppk is the way we calculate standard deviation. Okay? For Ppk, it's the overall simple. Just take all data points, and you just calculate standard deviation with this formula that I just said. Or you can go on Excel, on any software, just standard deviation of the sample using the 100 data points, all chocolates. Square root of x bar minus xi, the index, that varies from 1 to 100, power 2 squared, then divided by n minus 1, degrees of freedom, okay? Square root of that. Very simple, very simple. For the standard deviation used on Cpk, Then you have within. Within what? Within subgroups. Subgroups, okay? And here it will change depending on the subgroup size. So trying to keep it as simple as possible, think of getting the variation. In fact, it's the weighted variance of the subgroups, okay? It's the weighted average of the variances, and the weight is based on the subgroup size, okay? This is one of the ways to calculate. But what I want you guys to know is that regardless the specificities of how you calculate the within standard deviation, it is a picture that considers the standard deviation per subgroup. The overall performance, I close my eyes to subgroups. For within, I am trying to understand what is going on in one subgroup, in another subgroup, in another subgroup. Yeah? And then there are some very interesting implications of that. Very interesting implications. Because you may have a scenario where you have like, and let me see if I can do this by hand, okay? You may have a scenario where you have like 11, 10.9, 11, no, 12, 13, sorry about that. Sorry about that. Let me try doing something different here to explain to you guys. Random data. Normal. C3. 13. Okay, so let me take these 4 data points here and I'll place yes, 13, and then here I would say 7. No, 13. Okay, so let me take 4 data points here and I'm gonna replace here, okay? And I'm gonna take 4 data points here and I'm gonna put in this subgroup, okay? So let's see what we have now, okay? Let's see what we have now in terms of control charts. Too much. So let's go back here. Or you know what? No, this is just the perfect example, okay? Yeah. Now our process is not stable. But there is something very interesting here. There is something very interesting. Now, even knowing that I should not run a capability analysis, if I go ahead and I run my capability analysis, take a look. Who suffered the most if we compare with the previous performance? Who suffered the most? Cpk or Ppk? Take a look here. Who suffered the most? Cpk or Ppk? So see that before we had 0.65 for Ppk and 0.62 for Cpk. for ppk 0.65 and ppk and cpk 0.62. Now, who has changed the most? If we compare ppk 0.65 versus 0.53, so we got a reduction here of 0.12 versus a reduction of 0.03. Yeah, so ppk suffered the most. And we can even exaggerate here. For example, if I make this, for example, 1, 2, 3, and 2, 1, 2, 3, and 2. Take a look here. Now, ppk is 0.31 and cpk changed much less, much less. And why? Why cpk changed much less than ppk? Because ppk has the overall standard deviation. So I don't care if the problem is just in one subgroup. I don't care. I care about the customer experience. I don't care that it was concentrated in just one subgroup. I don't care. I have a problem. But who cares? Who cares about the fact that the problem, like we got chocolates by the weight of 1 and 2 and 3, like the chocolates were small like that. So ppk went down. ppk went down. Who cares, guys? Who cares about the fact? Imagine this situation. A chocolate factory, Mr. Wonka. Mr. Wonka. Customers are complaining because there were few chocolates. Take a look here. Few chocolates. Few chocolates. Just four. Just four. Highlighted in red here. Yes. Yeah, customers, that's an interesting point. Or let me rephrase my question. Do you think customer would care if you say, oh, this problem was concentrated in subgroup 2 only, so probably this problem happened only in the second hour of our production yesterday? Do you think customers, they care about that? Imagine that you buy a bottle of water, you are drinking this bottle of water, and then you see that there is a flavor, it's not the same experience as you had before. Then you complain to the customer, and then the customer says, wait, this problem is concentrated in one machine that ran last Thursday night from 3 a.m. to 4 a.m. But now the problem was resolved. So do you think customers, no, they don't buy that. They don't care. They don't care. I've paid for the water, and I want the water operating, at the right quality specs. I don't want to know. I don't want to know the machine that produced the bottle, for example. I don't want to know about the cleaning process. Type agree if you agree with that. I don't want to know the specificities. Yes, I don't want to know the technical, the process, specifics. I don't want to know. I am paying, exactly, Cedric. They expect the product to be paid for. Like when you guys take the white belt tests and sometimes the server get busy. I mean, even knowing that white belt is not exactly a customer, you are a lead, but you don't, I mean, it's a mistake on my side. It's a mistake on my side. You know, like my white belts, they don't want to know that there are 1,000 people, 4,000 people live taking the test. They want to take the test and get their certificates. That's it. But who would like to know that it is concentrated? Come on, guys. Who would like to know if it is concentrated in one subgroup? There is someone in this context. Try to think in the entire context. The Wonka chocolate factory, the customers, you know, who would like to know that, whoa, it is concentrated. Beautiful Charles, beautiful Vindra, beautiful Mervin. See, now there is an explosion of amazing, you know, the belts, the process workers, us, the analyst, the business, the process owner, the beautiful Mr. Wonka, the business, beautiful Annelise, Kelvin, Mufumelelo, Mares. So, mathematically speaking, PPK will take all data points and CPK will take another way to calculate standard deviation that considers individual, all subgroups, but it's a composition of individual subgroups, okay? But practically speaking, it's very simple. PPK is what customer is feeling. Once again, PPK expresses customer satisfaction. I'll say that again. PPK is customer. CPK is us. CPK is process analyst. CPK has to do with within what? Within subgroups. Obviously, we are investigators. We are investigators. Obviously, this information, by the way, who is working right now as problem solver? Type here for me. If you are working or if you have worked as continuous improvement analyst or manager or supervisor or engineer or VP or if you have your quality improvement or continuous improvement consulting firm, if you are or if you were in the past continuous improvement professional, okay? So we have a Sisifo, Charles, who else? If you are or if you have worked. Capability analysis helps measure the long term. Some ways to calculate standard deviation are more sophisticated than others. For example, Minitab uses gamma function to calculate standard deviation. Ah, Herman, beautiful. So we have many people here that work as continuous improvement professionals, yes? Question for you, when you receive, even knowing that normally we don't work specifically with outbreaks, but when you receive the news of an outbreak, production, we had to stop the production line. We have to discontinue production flow temporarily because we have a problem, major problem. We have a crisis, we have a peak, we have an outbreak. When you listen to that and you start your investigation process and you find out that the problems in the customer are concentrated in one specific production hour or one specific machine and one specific raw material batch, one specific operator, one specific method. When you find that your problem, all these outbreak is concentrated in a short period of time and or in one single factor level, do you celebrate or do you get sad? Do you celebrate as an investigator or do you get depressed? Celebration or depression? Celebration or depression? Celebration or depression? Type here for me. We have a mix. Let me try to explain in another way. We are talking about root cause analysis. Root cause analysis, the core principle in root cause analysis is segmentation, stratification. I love that. Annelise, depression followed by celebration. That's brilliant. Exactly this. So let me try to explain in another way. The core principle for root cause analysis is segmentation, stratification, meaning I wanna take the problems or the defective items, compare with good items, bad chocolates with good chocolates. And I wanna segment, meaning I want to understand the bad chocolates were processed when, where, by whom, with which material, so I can compare with this one. So in this case that we are analyzing process over time, if I see that good parts were produced all day long, but from 2 to 3 a.m., that the problems are concentrated from 2 to 3 a.m., the problems are concentrated from 2 or 3 a.m., this scenario as investigators, this scenario sounds easier or harder than if I find that there are problems at 2 a.m., other problems at 5 a.m., other problems at 1 p.m., other problems at 5 p.m. You know, the fact that it's all concentrated at 2 a.m. Apparently, initially, makes things easier or harder. Easier or harder? Type here for me. Much easier. Much easier. So ladies and gentlemen, for us investigators, we hate when the defective items are scattered, are placed all over the place, are all over the place. You know, we hate that. We hate that because it means we are lost. We don't know what to investigate. But if you tell me that the problems are concentrated from 2 to 3 a.m., you know, wow, now I can check the 6 M's: material, method, machine, manpower, environment, yes, measurement system, specifically at this period of time. Yes, so this is good news. It's good news for the investigator. And once again, PPK does not separate the data into subgroups, so we don't know. Based on PPK, we don't know if the problem is concentrated, you know, in one specific subgroup. And with CPK, you may know, not always. In the example that I showed you, where the standard deviation or the range is pretty much the same as the other subgroups, but the average has changed a lot, you know. This is the perfect scenario where CPK will be very helpful for us. Very helpful for us. Okay, let me see. Thank you for the engagement, guys. I love when I see the chat like this. And by the way, type here one word that translates. We have just started this year This Lean Six Sigma for all. Are you guys enjoying? Type here one word that translates how much are you enjoying this. Um, I work in process development before implementation. Constantly have to envisage what the main parameters are important. Quality indicators. Beautiful, beautiful. We know where's the problem. Yeah. I think celebrate because it gives us closer to finding where the issue comes from. Exactly, exactly. Yes, now you understood? Beautiful. Yes, exactly. It doesn't mean that it will be easy to fix. It doesn't mean that it will be easy to fix. Sometimes the problem is concentrated in one raw material and you have only one supplier and it's impossible to find another supplier. Sometimes in the world you have just one supplier, as we had in Nielsen for the portable people meter. Yes, for a long period of time, just one from China. Yeah, in aviation, it happens a lot. You have like your key suppliers, your key partners, and you must treat them very well because you have pretty much them, you know? So it doesn't necessarily mean that the solution will be easy. But the thing is, if you can find the root, before taking actions, you must find the root cause, you know? You must find the root cause. And once again, segmentation is beautiful. It's key, okay? We have to find the root cause. Yeah, and so once again, the main difference between PPK and CPK is the way we calculate standard deviation, okay? PPK considers the entire set, data set, you know, without considering subgroups, and CPK considers subgrouping, okay? Guys, just one final comment. I love sigma level because sigma level considers both sides of the, what do I mean by both sides of the problem? Meaning defective items below lower spec limit and defective items above upper spec limit. Cpk and Ppk considers only the worst side. So if you have problems on both sides, okay, on both sides, you are definitely missing something when you use CPK or PPK. But once again, we must know about CPK and PPK, mainly CPK, I would say, because CPK is very popular, very popular. Automotive sector is a good example of that, okay? Guys, I hope this 1 hour went as fast for you as it went for me. Thanks for your patience, because once again, I am on an improvised studio. I will be back in Brazil only in 3 weeks. Yeah, so the next, is that right? 1, 2, 3. Yeah, the next 2 sessions will be in the same place. Yes, I'll be back in Brazil at the end of Feb. And but once again, I didn't want to miss the opportunity to talk to you guys. And let me see, we have a last question here. Question, the goal of Six Sigma is near perfect quality, no more than 3.4 defects per million. So 1 defect out of 100 is terrible, hence my sadness. Okay, no, but the question was not about the size of the problem. It was not about the size of the problem. The question was about, we as investigators, it's like a doctor. We are doctors. We are physicians, you know, we are doctors in hospitals. Yeah, we doctors, good doctors, they love when they find exactly what's going on with the patient. You know, it's exactly like this. We are mapping out processes, not people. Sometimes people, processes, because it includes people. And we want to understand what is causing that problem. So when we find that the problem is concentrated in one single fraction of time or one single machine or one single person, we celebrate as a Sherlock Holmes. As a Sherlock Holmes. on an investigation point of view, because very likely everybody that's here, we are addicted to understanding things, right or wrong. We love to understand things. Yeah, oh, now I know why this is happening. Wow, now I know why we have some bottles of water that, you know, are delivered like this and sometimes like this. We love to understand phenomena. We love to understand. Right or wrong? Type here for me. Right or wrong? Yes. Empowering and motivating. Wonderful. Thank you, Professor. Value added. That's amazing. Wonderful. Guys, even if you are a white belt, okay, not a problem. And if you are a yellow belt or a green belt or a black belt, remember that nowadays at MF Treinamentos, we are working with basically three options. We offer white belt for free, and in case you are interested, you can become a black. Marcelo, but what about yellow, green? Black includes yellow and green belt, okay? And the last level, the top of the mountain, is the Master Black Belt certification program. Then you become my peer. Then you become a Master Black Belt as I am, okay? Guys, thank you so very much. And I am looking forward to talking to you all next Tuesday. Bye-bye.